those bases which does not dissociate or ionize completely in the solution and furnish lesser amount of hydroxyl ion is termed as weaker bases. For example, what we have? We have calcium hydroxide, we have magnesium hydroxide, we have ammonium hydroxide. This is all about the weaker bases. To the next, we will discuss the property of the bases. Properties of bases. What we have discussed till now, we have discussed the first one, that the bases are bitter in taste. The next one, bases are slippery in touch. The next one, bases are opposite of acid, or the bases neutralize acid. To the next, bases turn red litmus paper to blue. What we have discussed, bases are bitter in taste, they are slippery in touch, they are opposite of acid, or the bases neutralizes acid. The bases turn red litmus paper to blue. So the next we will discuss. Now we will discuss bases react with what? Metal hydroxide. Bases react with metal to give metal salt and hydrogen gas. Remember in the previous class, when we were discussing acid, then in that property we have discussed that the acid react with metal, zinc, H2SO4 react with zinc to give zinc sulfate and hydrogen gas. Here what we see, bases react with metal to give metal salt and hydrogen gas. Let us see it. When sodium hydroxide NaOH when it react with zinc metal, then it forms what? It forms Na2ZNO2 plus hydrogen gas. What we know? It means this is base. When base react with metal, it forms salt hydrogen gas. Clear? It means, let us balance it. 2 sodium, 2 NaOH. The next we have this hydrogen gas. What is formed? This sodium hydroxide reacts with zinc to form sodium zincate. Sodium zincate, and this one is hydrogen gas. This is also known as salt. Let us take another example, that is when sodium hydroxide react with aluminum, then it forms sodium aluminate. It means NaAlO2 plus hydrogen gas. It forms sodium when sodium hydroxide react with lead Pb, then it forms Na2PbO2 plus hydrogen gas. This is known as sodium plumbite. What we know? We know in this case the bases react with metal to give metal, salt and hydrogen gas. The next, the acid also react with metal to give metal, salt and hydrogen gas. So you have 3 examples here. When sodium hydroxide react with zinc, it forms sodium zincate plus hydrogen gas. When aluminum react with sodium hydroxide, it forms sodium aluminate plus hydrogen gas. Here, when lead react with sodium hydroxide, it forms sodium plumbite and hydrogen gas. To the next, we will discuss the base react with acid to form salt and water. This is also a type of neutralization reaction which we have discussed in the properties of the acid. That there we discussed the acid react with base to form salt and water. It is exothermic reaction, neutralization reaction. To the next, here we will also discuss the same reaction, that is neutralization reaction, because that is the property of acid as well as bases too. What means, when an acid react with base, it forms salt and water. So the next, it is a type of neutralization reaction. Because we have discussed an acid is going to nullify the effect of base and base is going to nullify the effect of acid. Because an acid is going to nullify the effect of base, and base is going to nullify the effect of base. That's why it is termed as neutralization reaction. We have also discussed that it is a type of exothermic reaction. During this reaction, During this reaction, heat is evolved. Heat is evolved. Therefore, it is termed as exothermic. Exothermic reaction. What happened during this reaction? Let us discuss. We know what an acid gives proton, that is H plus, and the base gives hydroxyl ion OH minus. It means it forms, they combine to form water. What we know? Acid has tendency to liberate proton and the bases have tendency to liberate hydroxyl ion. During this reaction, this proton from the acid and hydroxyl ion from the base react with each other to form what? Water. You know, acid has tendency to liberate proton and bases have tendency to liberate hydroxyl ion. Which react with each other, to form water. Clear? These are the next we will discuss the reaction of bases with non-metal oxide. In case of acid, we have discussed the reaction of acid with metal oxide, which forms salt and water. But now we will discuss the reaction of bases with non-metal oxide. Let us discuss reaction of bases with non-metal oxide. Let us discuss here bases. If we are discussing the calcium hydroxide, CaOH twice. This one is base. React with non-metal oxide, that is carbon dioxide. This is non-metal acid. To the next, they will form calcium carbonate plus water. This one is salt plus water. It means what we got, bases react with non-metal oxide to form salt and water. Bases react with non-metal oxide to form salt and water. This is also a type of what neutralization reaction, because this one is base and carbon dioxide, it is acidic. It means it is a type of acid-base reaction. But a question arises, does all the non-metal oxides are acidic in nature? No. Because what we conclude, all non-metal oxides are not acidic in nature. I will discuss few of them. Carbon dioxide, CO twice. It is acidic. The next one, carbon monoxide, it is neutral. The next one we will discuss oxide of hydrogen, it is also neutral. That means oxide of non-metal. Oxide of non-metal may be acidic or neutral. Clear? So the next we will discuss the uses of bases. We know the bases are used in bakery, such as sodium bicarbonate. It is used in fire extinguisher. That sodium bicarbonate react with sulfuric acid to give carbon dioxide, and this carbon dioxide is used as fire extinguisher. To the next, sodium hydroxide is used in preparation of soap, fibers, and it is also used in paper industries. To the next, calcium hydroxide, it is used in laboratory to test the presence of carbon dioxide. The magnesium hydroxide, which is a mild base, it is used to treat acidity. In this way, what we know, that base are very important to us in daily life. Clear? To the next, we will discuss the strength of acid and base, that is pH scale. We'll discuss the strength of acid and base, that is pH scale. We know that if we are provided with an acid, then by the help of litmus paper, we can test it as acid or base. It means by the means of litmus paper, we are going to distinguish acid from base and base from acid. But when we are provided with two acids, such as sulfuric acid and the next one, sulfuric acid and acetic acid, then in that case, how we will discuss, how we will know that which one is stronger acid? Because we have the litmus paper to test the acid and base, but when we are provided with two acids, that is acetic acid and the next one, sulfuric acid, and when we dip a blue litmus paper, the two solution will turn it to red. Let us see what is happening here. If we have one container, if we have what here H2SO4, and in another container what we have acetic acid, CH3COO. When we place a litmus paper into it, then this solution turns blue litmus paper to red. This solution also turns what? Blue litmus paper to red. It means both are going to turn blue litmus paper to red, but these are two acids, and we know this one is stronger acid and this one is weaker acid. Then how we will distinguish these two acids? In order to distinguish these two acids, 1909, Sorensen devised the pH scale. What? In 1909, Sorensen devised pH scale. Small p, capital H scale. That is only based on hydrogen ion concentration. It means in 1909 Sorensen devised pH scale that is only and only based on hydrogen ion concentration. It means we are going to distinguish acid with acid, base with base, and acid with base on the basis of proton content in it. We'll discuss how he is going to distinguish two acids, two bases, and acid and base. This pH scale, it is based on pH, small p, capital H is equals to minus log of H plus concentration. This is known as potential. This one is hydrogen. The full form of pH is potential hydrogen. It means what? Power of hydrogen ion concentration. It is equals to minus log of H plus. Why he used log? Because the scale was based on the concentration of hydrogen ion. And we know in 1 mole, or if we have 1 gram of water, in that 1 gram of water, let us take 18 gram of water. If we have 18 gram of water, then that 18 gram of water contains 2 mole of hydrogen. It means it is quite difficult to represent such large quantity. So for that, we use the pH scale. It means a solution contains